So we're going to be pretty familiar with the practices at the moment. We have things in our components such as read1, and all of these subscribe to an observable. The observables are then given to us inside our service, where it's either an HTTP post, which returns us an observable of our typed response, or it's going to return us an observable that we compose ourselves. So now it's time to implement this ability to update an existing item. So for us to do this, we need to load an existing item. So go ahead and go and grab any of these items that you wish to choose. I'm going to go with our Sour Supreme. What you want to do is take the ID, and then we're going to jump into the donut single. And instead of using an ID that doesn't exist, we can add one that does exist, which when we save it out, loads it in nicely. So let's assume that we're an admin of this application and we now want to go and update our particular donut, or perhaps we want to say it's a limited edition now, or change the description, any of these properties we want to change. We can do this by hooking into our onUpdate. In the same way that we are using our donut service create, we can then listen to our subscribe when we go and implement this inside of the update. Now this gives us the exact same object. So what we should do is go and set this up. We can say subscribe, pass in a function, and we can say console.log, and then updated successfully. Now if we save this, this is going to give us a big error. Now this is quite a helpful thing with TypeScript. Sometimes it's a little counterproductive because we might have to implement a bigger feature, and when we press save in one place, it's then going to give us an error in another. But this is a practice that I quite like to use, is to type the code that doesn't exist, and then as soon as we've provided an implementation, it then goes and works out of the box. So inside of our donut service, we already have the logic for our update. So in the exact same way that we are making a create request, we're then posting off to our donuts API, and then inside of a pipe, we're then passing in a tap function to jump out of our observable stream, which is created by the pipe. And without having any knock-on side effects, we are simply grabbing the data and then doing something with it. So this is a really nice pattern to manage our state, and it helps to keep things really nice and readable. So what we want to do now is update our particular item. So for this, we're going to do the same as above. We can say return this.http. Now instead of using a post request, we're going to use a put request, which is then going to be used to update a particular item. The item that we're going to update is a donut, because we're going to then get this back, and we can use some backticks to again supply our API. If we have a look, we have API/donuts. So we're also going to be hitting the same API endpoint. However, we need to update the one particular item instead of looking at this entire donuts collection. So the way that we can do this is by passing in the ID from the item that we want to then update. So our JSON server fully supports this functionality, which means in the same way that a real REST API would work, we can interpolate and pass in our payload's ID property. Now, because this is a put, in the same way that we pass the data above inside of our post request, the difference here is we're adding an item that doesn't exist and we're passing the payload, and here we're updating an item that does exist. So we then need to not only supply the item identifier, we also need to pass in that updated item. So then we can say we want to pipe. We then have our tap function. Now I'm just going to type out the body of the function and then hit save, so we can then see things a bit more clearly on some new lines. So it's at this point that we have our logic available. We don't need our console log anymore. So once our put request has finished, and we'll check this out in the developer tools network to actually see this go through, we then have this tap, which gives us the updated item. Now in reality, our payload object is going to be the same as the donut object, which is then given to us back from the server. Now it might be in a real world scenario, you have different properties that get given back from the server. So it might be a good practice for us to take this definition instead of our existing payload and update our data structure with the one that's given back from the server. For example, we might have a created app property, which will stay static, and we might have a modified or last modified property. So our server can be in charge of providing us perhaps a last modified property. Now we don't have this in our application, I'm just using it as an example for you. So if we grab our existing code, we can just simply drag it up, add it inside of our pipe. Now for us to hook this up, like I mentioned, we could keep our payload. I'm going to use this donut. However, we do in fact have a naming conflict because we have donut specified in our existing code. So what we could do is rename this over to item, so we can then compare the item's ID, and then our payload can just simply be the donut that's come back from the server. Now the reason I'm doing this is because we have tap, we have donut here and donut here. So I'm just doing this to keep the names of our variables nice and consistent. So what's going to happen? Our put request will be made. We pass in the ID of the item that we want to update. We then supply the item in its updated form. We then break out before our response gets returned to our single component, and we'll talk about this in a moment when we look at how we subscribe. We then get given that individual updated donut property back from the server, and we then reassign the value of our donuts, because what we're going to do in the next chapter, after we hit update, we're then going to go back to the home page and we're going to see those changes being reflected instantly. And they're instant because we are updating our state, which is then going to be shared amongst our components. So the updated state will be the result of calling donuts. We're then using a map to supply a new array. Any items we're going to just pass back that do not match the ID of the item which was then updated. And that's pretty much it. We're just making a quick swap in our data structure based on the item that's come back. So let's save this out. We'll jump into our DevTools. If you head over to the network panel, we can expand this slightly. And we can select fetch/XHR, XML HTTP request. We'll hit refresh on our application and we can see that a request has been made to our initial data because we're providing this read functionality. Now we have Sour Supreme. What if we change our price over to 149 and we'll also supply it as a new? Now if we hit update, this is then made a request to 8AM KZ9, which as we know, if we jump inside our single component, that is the ID of the item that we're requesting. We also have confirmation inside of our terminal. You can see we have a put request and it's come back as 200, which is A-OK. We'll then have our updated data structure being handled behind the scenes. And if we inspect our network request, we can then see our new promo property of new and the price of 149. So everything here has been taken care of as we'd expect and handled correctly. We can do a final piece of confirmation, jump into our db.json, and you can see that our fake database isn't actually reordering things. It's just updating the exact one that we asked it to. So the way that it uses these IDs is to act as some kind of REST API, where it allows us to efficiently develop and update as if we were dealing with a production database. So I really like using this. So that's how to handle our updates. I think that was quite simple. We've moved our existing logic. And the reason that I've taught you this in this order is because it breaks out the thinking. If we were to create a service and have a HTTP request and then start updating some state, it would get all too confusing. So the reason that we've attacked these separately is because you can think about them differently. If you don't need an API, you now know how to write your own state and handle the state in the service. And if you do need an API, you now know how to jump out of it, set some state, and then request it in another component. So let's carry on. We're going to implement in the next video our ability to delete.